Welcome to today's Postgres conference webinar, SQL for Time series using QuestDB. We're joined by Vlad Ilyushenko, co-founder and CTO of QuestDB, and Brian Smith, technical writer at QuestDB, who will discuss how to store and ingest in QuestDB, how to use popular PostgreSQL clients with QuestDB, and why ANSI SQL is a perfect fit for time series data. My name is Lindsay Hooper. I'm one of the Postgres conference organizers, and I'll be your moderator for this webinar. A little bit about your speakers. Vlad is the co-founder and CTO of QuestDB, the fastest open source time series database. Vlad started to work on QuestDB in 2013 as a research project and has 2 decades of experience as a software engineer in low latency FX equities. Brian is a technical writer at QuestDB who loves building great developer documentation and hacks on open source software, Swagger docs, Python, Node.js, Ruby, Arduino, and IoT. Welcome to both of you. With that, I'm going to hand it off to our speakers. Take it away.
Thank you, Lindsay. My name is Vlad, and as Lindsay introduced me, I am CTO and co-founder of QuestDB. We are a fairly young company. We started this company kind of about a year and a half ago, and prior to that, I have been kind of developing this as a side project, as Lindsay mentioned. We're just going to hop to another slide real quick, and we posted a summary on the Hacker News about the origins of where we started from. I guess just to summarize it really quickly, I've been working with databases kind of all my life, really, just right from 1996, if I can remember this correctly. And the kind of realization kind of came that when people work in a trading environment, financial trading environment, databases are just not used at all. And the one that was used was KDB. And if you guys know what KDB is, I suppose it's a really fast database, but it's a proprietary database at the same time. It's expensive. It's a consultancy-driven kind of business model, and the language is, well, not very accessible, hence consultancy model around it. And kind of my idea was to build something similar like KDB, perhaps faster if I can, and I would use SQL as accessibility language. And maintain the performance profile of KDB, and also not to mention in this trading environments, they're a little bit of a club, and to me it just seemed unfair that sort of very few people kind of experience high performance tech, and people who are not part of the club, they don't get to use anything like that. And yeah, this was one of the motivations behind building QuestDB. So I don't know if I'm sure you know about time series, what time series are, and it's just a data type, I suppose, where data is accumulated over time, typically with a timestamp, and the use cases for time series data kind of centered around first acquisition of it. And sometimes this acquisition needs to be done at sort of consistent speed if you're dealing with the hardware that produces the data itself. And the second use case is analytics over which has time element, like you would do analysis over time windows, various things. Yeah, and if we just flip back to what Lindsay kind of mentioned, we're going to talk about is the structure of what QuestDB is. The database is first column based. So this column-based approach kind of lets us effectively minimize lifting data from disk if data is not needed. Some of you may be familiar with this type of databases, but we kind of use memory map files to map the data into memory, and if columns are not accessible by SQL query or otherwise, the data is not even picked up from disk. So it just kind of speeds up disk interaction. And likewise, the other kind of interesting kind of element about column-based structure is that some of the analytic queries can be parallelized by columns. So several columns can be processed simultaneously in a shared nothing approach. Cool. So I guess the next thing is we store data in time partitions. So that's the only partition method we support kind of right now, and the time element can be day, months, or year, and perhaps we can introduce more time elements. These partitions stored on disk as a separate directory, so they should be kind of relatively easy to manage in the sense that when you look at time series data, perhaps all the data might have sort of lower value to people compared to newer data. And with the time partition kind of data model, it's relatively easy to remove data that is becoming stale without incurring kind of any performance sort of any data reshuffling. So you just kind of quite literally remove directory for this time period, and that's it. And another kind of hidden benefit of time partitioning is queries that are performed on time, they take into account this partitioning, and they shall we call it like call partitions that do not fit in, that do not participate in the query. So that's again, we do not using sort of time partitions, we avoid lifting data from disk that's not needed at all. So that's another thing. And the third, like columns, partitions lets us parallelize analytic queries. So effectively, once you have a column-based model that is partitioned, in effect, you have data grid that can be parallelized as a grid. So each cell of a grid can be computed independently from other ones. That's so far is the storage. I guess the limitation of this model as of so right now is that this model is append only. So I guess the advantage is append only is a very simple model. It's very easy to add data to existing data set, and this I guess the advantage where we can kind of use it to use as advantage is the ingestion speed into this model is very high. The drawback, and I'm going to touch on this, so the drawbacks on the next slide, but the drawbacks are two, right? First, it's not very easy to remove data granularly from this model. So if you wanted to remove a single row from a data set, that sort of needs a data set kind of rewrite. And the second is when data comes, for example, with a time delay, it's relatively tricky to insert data into this model that sort of, if it didn't come naturally with timestamp incrementing. And for this particular scenario, we sort of just about to ship what we call out of order ingest is a system that would allow randomly ordered data to be to be ingested in our existing column-based and time partition model. So that's what we're working on, and this is going to be our kind of next and biggest release actually. And the storage, speaking of consistency, the storage is, I mean, it's not compared to consistency and ACID sort of compatibility of Postgres. QuestDB is not fully there, but we provide repeatable read and isolation per table basis. For example, it's possible to ingest, a system could be ingesting data continuously, and the reading application or user would basically only be able to read committed data. So they cannot read data that hasn't been committed to a particular table. Our transactions do not span multiple tables yet, so it's a per table affair. In essence, this model is quite optimized for ingest and concurrency. For ingestion, append helps. For analytics, we use SIMD instructions and highly parallel analytic functions to query data reasonably fast from the database. I think that's that for that slide. Lindsay, any questions so far, perhaps?
Yes, we have, let's call it 1.5.
Okay.
The half first, because I think it's been mostly answered. I just don't know if you want to expand on it. Does the entire data set need to be able to fit in memory?
The answer is no. So what needs to fit in memory is only active part of the data set. We lift data in memory lazily, is what accessed by queries. And we also expire data from memory if it's not repeatedly accessed. So in essence, the answer to this question would be, if you for example have a table with say 100 rows and say 1 year worth of data in a table with 100 columns, sorry, and 1 year worth of data, you query 3 columns for 1 day, we would only lift in memory 3 columns from a partition for that particular day. The rest of the data is physically not touched. I don't know if this answers the question.
Wonderful. And the second question, if data is received out of order, will it be stored out of order or sorted first?
The current release, it's very current, well, our latest 5 or 6 release would reject data out of order. So it would just not allow data like that for sake of preserving the timestamp order of existing data. So the new release 6.0 will ingest data and store it sorted. So to end user, this would look like data was received in order, if I were to give, for lack of a better example, really. So the data is sorted first, then stored in a vector on disk.
Wonderful. That's all the questions we have at this point.
Awesome. Okay. Kind of next, what database is not. So we are not very good at kind of transaction processing. If the use case, and there have been quite a lot of people asking whether they can update, like routinely execute an update statement data, we cannot easily do that. And likewise, we cannot easily delete data granularly. If somebody wants to take a record out of the data set, we can't do that. And we also we kind of right now, we not a data lake in the sense that we sort of require relatively sort of big compute engine for the data. So, for example, we are not yet interacting with cold storages, cloud cold storages. That's on the cards yet, but not right now. So we use memory map model for pretty much all the data we access. Right. So QuestDB integrations. I wonder, Brian, do you want to talk through that?
Of course. Yeah. Thanks a lot, Vlad. So it's as Vlad mentioned. So we have quite a few integrations, and being as Lindsay introduced. So I'm a technical writer at QuestDB. So that means I get to write a lot of the example code and user guides for all of our users to be able to try out QuestDB. So that means I get to try out a lot of pretty nice tools and learn some stuff along the way. So we have three main APIs that that you can interact with QuestDB from. The first is the REST API. That's basically what's underlying the web console and user interface that ships with the database. Then we also have ingestion over InfluxDB, and then we have Postgres compatibility. So these three APIs are useful for a lot of different use cases depending on what the application that you're using. But of course, the Postgres compatibility lets us use quite a lot of nice tools. And I am going to give a demo for the next maybe 15 minutes. So we'll have a hands-on session and see what that actually looks like. So let me just share my screen. So good, right? So there's a few ways that you can install QuestDB. You can use Homebrew. If you're on Mac, you can run binaries. But of course, one of the easiest ways to get started is with running Docker. So that's usually how I like to run a lot of my examples, as it's just the most portable and it's pretty close to where you're going to be running it in production likely. So, okay, so let me just explain what I'm doing here. So I'm going to open port 9000. That's for the REST API. Then we need 8812. That's for Postgres. And then we need 9009. This is for InfluxDB line protocol, and we'll use that later for some ingestion. So we can just run the latest tag, which I pulled earlier, and we should get Quest running here. Okay, so the first thing that we see on port 9000 there is the web console. So we can take a quick look at what we have to actually interact with. So up on the top left, we have a table schema explorer. So there's two tables that are created by default, which you can disable, but this is for telemetry. This panel up on the top right is a SQL editor, and that allows you to write SQL for these tables. And then on the bottom, we have the results. So great. Okay, I have the web console up and running. So now I need some data. So what we should do first of all is let's try out a node example. So this one, for those of you who are familiar with the PG package, this is probably fairly simple. So first, we're just setting up a basic connection using the Postgres client, using the default credentials, port 8812. And the interesting thing is we can run a SQL query directly from this client. We can also run parameterized queries and log the results there, and then prepared statements if we want to. So it's fairly simple to get started with loading some data from Node. So, okay, we've logged the console results from inserting a row, inserting prepared statements, and then we can check over in the Schema Explorer, did our table get created? So we have a new table trades here, and we can see this is just the output of our node script. Okay, so that's if I wanted to try out using some different client libraries. But let's say I had some CSV data and I wanted to load this in bulk. There's another option here to import. So one thing that I thought would be nice to show is this taxi trips data. And this is half a gig file, CSV file. And this is taxi data, New York City taxi data from February 2018. So I think this data set gets used in a couple of different examples. It's a really nice one because it's quite large and there's a lot of nice practical queries that you can do on this. Okay, so let's check back on the query editor. So we have a taxi trips CSV file. So here, if I click on the table itself, then I have a nicer way to actually explore the columns. So I have my pickup date time as a timestamp column, a couple of other different values such as the trip distance, payment type, and I can run some SQL to check what's in this. Select all from and my taxi trips. So this might be the interesting. So here we have just over 9 million rows, and we're returning these in 46 milliseconds. So we can see in this notification here that the execution time for this is 25 milliseconds. So this is quite nice to be able to run SQL over such a large data set and have pretty much high performance reads over data like this. So I think there's a few other optimizations that we could do using the types, but at least from bulk importing data to getting results back, this is quite good. So let's have a look at one of the topics that we mentioned in the subject of the presentation, which was SQL for time series. So what ways can we use SQL to ask questions about time series data? So first thing I'm going to do is I'm going to rename this because I don't like my taxitrips.csv as a table name. So I'm going to rename table taxi trips to taxi _ trips. It's just for convenience. Okay. So maybe I'm interested in what the payment types are. So I can see that we have some payments in cash and card. We have some that are unknown. What if I wanted to group these by payment type? So I want to maybe select the average trip distance and the payment type from my table, taxi trips, group by payment type. Okay, and I can just select the SQL itself in the editor and hit F9. So here, what we've done now is grouped all of the payment types together first. So the SQL execution is to group by first, and then we've done averages over here. So this is a nice way for us to get very quick averages on quite a nice 9 million rows. So we can see that this executes in about 700 milliseconds. What if I wanted to have a bit more of a granularity on this? So I don't want the whole table, but I want to maybe.
Hey, Brian, can I interrupt you for a second?
Yeah, of course.
I think your screen has frozen.
Oh, really?
Yeah, do you want to try moving your mouse for me?
Yep. Can you see this?
No, I cannot.
No. Okay. Let me restart that. Thanks.
Yeah, absolutely.
Okay. So maybe okay. Let me hand it back to Vlad and for the moment, because it seems like the screen share isn't working on my side.
Thanks, Brian. Let me just share my screen. I don't have interactive screen. I only have the slides. But yeah, so I guess the one thing that Brian wanted to show is basically the queries that the extensions that we added to SQL, right? And I'm just gonna start backwards here from the times. Yeah.
If you want, Vlad, I can walk through some of the examples that I was about to show.
Of course, Brian. Sorry. Yeah,
so, okay, so of course, being able to sample by is really helpful, because here you can split the entire table up into chunks that you want to perform aggregate queries on. So sample by is very useful in this case. Then of course latest by is another great one for finding the latest value of the data set per column value. What I was about to show in the demo itself was more along the lines of the integration. So it's very easy to set up a Grafana integration by using the Postgres connector here. So this Postgres plugin is provided by the community. So that allows us to then very easily have integration with a lot of the other tools that go with the Postgres ecosystem. So depending on the use case, typically you would be using, Vlad can probably add a bit more color to this, but typically you want to be using InfluxDB for very high InfluxDB line protocol for very high throughput scenarios, or where you have multiple clients writing. And Postgres is quite good for a lot of the additional tools that you can use, for instance, like Grafana, to be able to monitor what and visualize what the data set looks like.
Cool. Thanks, Brian. Maybe we can. It's a damn shame that Brian screen share doesn't work.
Absolutely.
What they're gonna try and do is we've got a demo server. I'm gonna try and basically see if I can. Oh, sorry, I'm just keep clicking everywhere. I just want to minimize this on a second. Okay, so let me just try like a demo server. Do you guys see my screen here?
Looks good.
I do.
Oh wow, that's pretty cool. So yeah, so basically this Brian, do you want to actually, you can control my screen, so let me just do it. Let me do this. So this is the similar thing that Brian loaded, but it's a little bit bigger. So this is 1.6 billion rows here. You can access this data set yourself if you want. So this is fully sort of, you can type SQL. Actually SQL extensions, of course, yeah. So you notice basically we made this select star from optional here, so this is the same thing you can run, but if you don't want to type select star from, so you can go just do table. It looks a bit weird.
Hey Vlad, do you mind increasing the font size a little bit?
Oh yes. Voila.
Yep, much better.
Okay, very good. So yeah, this is that's the data. So let's suppose we want to find data timestamp extensions, right? So where pickup timestamp equals, and we have like shortcuts to, for example, to find say 2010 only. It's the year 2010, right? And that's, I don't know if you can see this tooltips. Basically, it takes us like 3 milliseconds to find 2010, and that's not a fluke. You can find 2014 basically at the same speed as well. So that's basically, this is where effectively partitioning data, it becomes beneficial, because we're literally scanning absolutely nothing. We just pick up kind of partitions that constitute 2014. But you can we can further here say on March 2013, on 10th of March, right? And that's again time it takes to get a day, and you can descend into time you wanted to get, say I don't know, 8 p.m. right? So and this is basically, again, this time is very easily accessible.
So Vlad, let's say, because I have my queries here, but let's say I can ask you, right? Let's say if I wanted to get a weekly average from some column, how would I do this? Let's say I have a passenger count. So if I wanted to get the weekly average of the passenger count from the trips table.
Right, so select count, no timestamp. I'm just improvising here. Thank you, Brian, for putting me on the spot now. You can do sample by 7 days, right? Let's see how that works. I've got so many pop-ups here. Let me just close some. I can't see my data. Yeah. So this is basically kind of weekly averages of passenger counts. Any more tricky questions, Brian?
I have lots.
Okay.
So if I wanted to select the latest by a certain value in the table, like so we have the cab type as a symbol. What if I wanted to select
okay, so let's just do, say, select distinct cab type. Distinct cab, is it cab type, right? From trips, because I don't remember the values, right? Yeah. So then the yellow and green, and we can say, yeah, this is not very representative query. Cab type. Yeah, so these are like the last 2 rows from the entire data set for these cab types. But you can do basically this type of query. Basically, it's used if you want to have, for example, if you have ID of something. So cab type is not a very good ID. If you have an ID of an object, and you want to preserve the history in a time series database of all the evolution of fields of this this particular entity with this ID, and then you want to get the latest value of this evolution. So we introduced latest by keyword, right? So I can do something bigger, maybe this rate code ID is a little bit bigger here. I don't know. Yeah, so this is sort of slightly slightly bigger, but just to remind you, this is 1.6 billion row data set we're kind of going through, right? So Brian,
thanks, Vlad. Thanks, and I'm sorry for putting you on the spot, but I think that's pretty cool.
Yeah, and just kind of let me just show you something else, basically, which is column-based things. So this again, this kind of, we can calculate average distance over entire trips table. Oops, I need to select this, right? So, and this effectively time it takes to calculate. Well, this is a single column. It's about 11 GB in size generally, this column, and using parallel algorithms, it takes us this long to calculate distance. Sorry, the value. we're not fully there yet. We haven't optimized every single query under the sun yet, but we definitely on the way of basically doing it. I don't know. There's one other thing as well. We've got this weather database here as well, and this shows, I guess, this weather data set is a little smaller. What is it? 137,000 rows. And this is exactly the same thing. This is averaged by a month from entire weather data set. Just remove this pop-ups. Yeah. So that's the data. And also we kind of, it's not a database feature per se, but we kind of in the UI here we built sort of a virtualized grid. So this grid does show kind of a lot of rows. You can go like by a keyboard, you can go at the end of this grid pretty much. You can scroll it up and down. So I'm scrolling with the page up right now. So you can inspect all your vast data estate if you wanted to. But as I said again, you can evaluate this, go in the demo, see what works, see what doesn't. Just feel free to knock it out. Brilliant. Brian, did you want to show anything else from your demo you can't share?
Thanks. So I wanted to show latest by, which you demoed. A sample by is also quite a good one, where the table itself is then chunked by a particular a time range. So you can have sampling by 7 days or by 1 month, and then perform an aggregate on top of that. Yeah. So yeah, this is the weather we're showing it. So this here you can this called months, and you can do say 3 days or 15 minutes, that kind of stuff. So this would also work. And we're looking to improve on the sampling algorithm a little bit more in a way, well, obviously make it a little bit faster than it is, and also give a little bit more parameters to it, because a lot of our users kind of asking to specify more sampling parameters. Linz, are there any questions so far? Because yeah, Brian and I are talking to ourselves.
No, we've gotten 3 good questions in. So the first is, what kind of limits are there on the number of dimensions? Can my time series have thousands of dimensions?
Yeah, this is a very good question. This is kind of known as a cardinality issue with other time series databases. So let me just explain how this works. So we kind of store dimension, like let me just elaborate a little bit here, right? So we store, let me just do say select distinct cab type, right? So the cab type is a dimension of some sort, right? So we store it as a symbol. It just says here symbol, right? What symbol is effectively is a map between string value and the integer value. So we do not store these strings yellow in the database. We store, for all intents and purposes, 0 and 1 in the column, right? So when we ingest data with high dimensionality, right, what we're faced with, we need to do quite a lot of lookups from string to back to int, right? And that's the limitation, right? So what we're doing with the 6.0 release, we are able to parallelize all of these operations. So we can scale effectively these lookups across your entire server, as many cores that you have, you can throw at it. So the limit would boil down to your CPU capacity or CPU capacity you've given to QuestDB, because you can limit the resources it uses on the machine. B, it's basically number, obviously, of dimensions, and C, number of distinct values in each dimension. So all of these kind of methods, right? But we happily ingest, effectively per table, we ingest, I don't know, like 50 different dimensions on a single time series. And moreover, this sort of those limits I just mentioned are per table, right? Other tables can function completely independently from one another. So I would go as far as basically saying we don't really have a cardinality issue in the sense that the database have it. And all of these limits kind of need to be explored sort of based on what type of data you store. Sorry, it's a long-winded answer, but happy to elaborate more if need be.
Wonderful. Another question. In the trips table, there are more timestamps. How do you specify which one to use for arranging and partitioning?
Yeah, thanks, Lindsay. This is very good thing. So there is a notion of kind of dedicated timestamp in the table, and in this table we actually need to improve UI. It's this column. UI doesn't show it, but I know it. So it's basically pick up datetime. And this table, this column drives the natural order of records in the table. So the values in this column will be used to physically order records as they stored in vectors, right? Now, this puts a limitation, so you cannot have more than one timestamp on a column, right? That's the difficulty, right? And if you want to do the same kind of same tricks on this timestamp, is going to be a lot slower to do, and the only way to deal with it is to add an index, which we actually do not support on a timestamp type. We support on symbol type, but not timestamp. But we can add if need be. So far, all our sort of use cases kind of needed only one timestamp. The taxi data set is a bit less representative because it has two. I don't know if I answered this to your satisfaction.
Let's go with yes. Okay, we got two more questions that have come in, and then I will let you guys get back to it. The first one is, can we explain queries?
Explain as in explain plan, I guess.
Explain as in all caps explain.
Yeah, you can also. This is one thing we wanted to take away as well. I mean, like, I don't mean it in a bad way, you know. So we kind of basically want database to work all the time, right? So we kind of wanted to step away from having user to okay, discover that SQL doesn't work, right? Then have a look at the plan and maybe add an index or reorder tables or where clauses, right? So we do have full featured optimizer. So SQL, we kind of look at the SQL as a declarative language. So optimizer is there to work out the best plan there is, right? And we wanted to keep improving this optimizer, not to miss anything. And also, we do not want to rely on indexes for as long as we can. So far, basically, people who used QuestDB, they sort of never asked for explain plan. And we so far haven't focused. We do have internal plan for sure, but we don't have like explain plan sort of SQL command to get it out in the grid, but we can add it. We do have plan internally, but even if we get it out, I don't know what you can do with it really, because there's very little to influence it.
And the last question for now, could you show a slow query wrongly chosen condition?
Yeah, so this Yeah, slow query. Okay, there's one thing on slow query. So we don't really implement filters well. So let's do trips where this greater than 10 for sake of argument. This is going to be slow because we didn't optimize filters as well as we could, right? So this is going to be, I mean, here you're going to feel how much data really is there, you know, underneath. That's a lot, right? But the good thing is, though, if I actually click cancel here, it actually stops execution on the server, right? So it basically, we try not to consume tons of resources, but yeah, this is what it is. So you basically cancel it and it just goes away. Server stops executing it altogether. Yeah, that's the slow query, and we're gonna probably run out of time waiting for that thing to complete. Actually, I'll show you some other queries. Like people were trying to say do stuff like that. This basically, we support joins, by the way. So we support inner joins, outer joins. We support actually, I'll show you another join kind of we support. But look, this usually kills the database, right? So if you multiply 1.6 billion by 1.6 billion, right? So it's not going to be slow. Spoiler alert. Oops. Okay, we'll just call it A and B. So, and this is basically this is number of rows. It's selected, and this is the time it takes, right? This is basically kind of it doesn't really do that much rows. It just optimize the knows what you mean by not tripping over, right? And there's basically, we've got another query. Where is this called? As of query. I'm just wondering if we have an example here. Yeah, is it? There's so many pop-ups, I can't see anything here. Yeah, okay. So, and this is basically, this is example of as of join, and this is time series fuzzy join. So the way it works, it basically it say it gives you the weather for the trip, right? Kind of the latest weather just before the time of the trip, if that makes sense, right? So it's fairly complicated to do it in normal SQL expression, but we kind of introduce as of join, and it uses dedicated timestamps on both columns because this thing knows which column is what.
So this is where we're able to correlate data between two tables by the timestamp values, right?
Yep, that's right, Brian. Linz, any more?
Not at the moment.
Right, very cool.
So thanks a lot for the demo, Vlad. That was super, and it turned into how to break QuestDB.
Okay, but you can, as I say, you can just go back to demo and destroy it if you want. Yeah, so let me just do the present back here so we get back on track. Okay, so this was the question part, and the roadmap. What are we trying to do basically? So there's imminent release of out of order ingestion. This is what we're working on really hard. We've got alpha and beta releases. There's still lots of bugs. Basically, we're trying to solve problems that arise from kind of people using it. But yeah, it's coming out. We also have been working on the replication for quite some time as well. This is not made it in the release yet. There's some work outstanding to be done on this, but it's third quarter of this year. And next year, with a bit of luck, we should be able to roll out a fully hosted solution, entirely hosted solution that would support perhaps one cloud to begin with, and then we'll gain basically other cloud support over time. Cool. And yeah, and this in very big letters is the URL where you can go and find the demo and try and break it. Just take it easy though. Cool. That's all I have really, guys. Thank you very much for for joining and listening to us blabbing about QuestDB. Hope you like what we do, and what we really want you to, well, we would really appreciate if you kind of provided us with any sort of support ideas. If you try it, if it works for you, it doesn't, we just want to know basically all good and bad. We want to improve the product. Yeah, thank you. Linz, over to you.
Brilliant. You know, I have to say, you guys rolled with those punches so well. You guys made it look seamless. So with that, guys, thank you so much, Vlad, Brian. This was fantastic. Again, you made it look like this was what was supposed to happen the entire time.
Maybe it was. No, thank you very much, Lindsay.
You'll never tell, right?
Of course not.
And all of our attendees, thank you so much for spending part of your day with us. I hope you enjoyed it. I hope you learned something, and I hope to see you on future Postgres conference webinars. Cheers. Thank you all.
Thank you.